This is a homework problem from the Unit 1 Lesson 1 homework on vectors. This is problem 11.1.084 from the Larson and Edwards Calculus textbook. I have not rewritten the entire problem here, but I wrote the most important information. So we're told that we have a plane and it initially has a ground speed of 430 miles per hour due east. And as it's traveling 430 miles per hour due east, it encounters a wind from the northwest of 37 miles per hour. Then the problem statement says, find the airspeed and compass direction that will allow the plane to maintain its ground speed and eastward direction. So I've just added this right here. That's going to represent north. South, east, and west. This is our initial ground speed, and then it encounters a wind of 37 miles per hour. Now, since that wind is coming from the northwest, if this is north and this is west, coming from the northwest implies that that angle that we're making with the vertical or the horizontal is 45 degrees. So that's 45 degrees, that's 45 degrees, which means that's 45 degrees. Now, if in this problem statement we were asked which way the plane would be flying after this wind affected its direction, we would just be adding these two vectors. We'd take this vector and add them together. But that's not what we're asked here. We're asked to find the new airspeed and compass direction that will allow the plane to maintain its ground speed and eastward direction. So the plane has to keep flying this way, ultimately, even in the presence of this, extra wind velocity. So in other words, what we're looking for now is we're looking for the appropriate speed and direction for the plane to go. So this vector plus some other vector is equal to this vector. This is what we want our resultant vector to be. So I want the velocity of the plane plus the velocity of the wind to equal this velocity, which is 430 miles per hour in the eastward direction. I'm thinking of my north, south, east, west, superimposed on the XY plane. We can think of that as 430 times I hat, or we can write it in component form. I prefer component form myself. Now we know what the velocity of the wind is, and we're asked to find the velocity of the plane. So we can just take this equation and solve it for the velocity of the plane. And that's almost going to get us there. Because ultimately we're asked for the airspeed and the compass direction. So what this is going to get us is the velocity of the plane in component form. But if we want the speed, we'll have to find its magnitude. And if we want the direction, we will have to find the appropriate angle. So we'll take the velocity that we want, that final velocity, and we'll subtract the velocity of the wind. Now, the velocity of the wind is this represented by this vector here. We're going, if we split this into components, the component in the x direction, sorry, I'm looking for a marker. The component in the x direction is adjacent to that 45-degree angle. So it's going to have a magnitude of 37 cosine of 45 degrees because it's on the adjacent side. And the component in the y direction, notice it's pointing down and not up, so it's going to be a negative value. That will be negative 37 sine of 45 degrees. So if we subtract component by component, we'll have 430 minus 37 cosine of 45. And then we're subtracting a negative, so we're going to have to add 37 sine of 45. And I can write the exact answer this way, or at least the exact component form this way, because we know sine and cosine of 45 degrees are square root of 2 over 2. And we could approximate this, but we are going to approximate our answer in the end. We're asked for the answer in decimal form, and we're asked to round to 2 decimal places. I don't want to carry any errors forward, so I'm not going to round here, but I will round when I find the magnitude. So the airspeed is the magnitude of this plane velocity. So we're just going to take those components, square them, add them, and take the square root. So we've got 430 minus 37 times the square root of 2 divided by 2. I want to square that and then add 37 times the square root of 2 over 2. Quantity squared. That's that squared plus that squared. Oops. Something, it's not what I want. There we go. And I want to take the square root of that answer. So I'll use square root, oops, delete, square root of answer. And I get approximately 404.68. And all of these units were in miles per hour, so this is miles per hour. Okay. Now, another way that you can think of this is that this velocity plus this velocity has to equal that one. So I want to draw a slightly different picture. What we're saying here is, let's say I've got an airspeed of 37 miles per hour, and that's making a 45-degree angle with the horizontal right there. And we want our resultant speed to be 430 miles per hour. This velocity here is the velocity that's required to get us back on track. So we're taking that airspeed plus that velocity to get that 430 miles per hour going due east. Okay, now if you look at this vector, you'll notice that it has a component in the x direction that's positive and a component in the y direction that's positive. That's exactly what we have here. And the magnitude turns out to be this. Now, if we're looking for an angle, just use a little bit of trig to find that angle. So if this is my y value, or excuse me, my x value, and that's my y value, and I'm trying to find what that angle is, that angle right there. Well, the tangent of that angle is the y component divided by the x component. And I'm just going to write that out in words. I know in physics class you use a subscript with a y. We're not going to do that here because we're going to use that for partial derivatives later. We're going to take our 37 root 2 over 2, and we'll divide by the x component, which is that 430 minus 37 root 2 over 2. Okay, so the tangent of our angle is equal to this. So theta, that's the angle with the horizontal, is going to be the inverse tangent of this. So the way I enter that in my calculator is I will do the quotient first. I've got 37 root 2 divided by 2, that's my numerator, divided by, open parentheses, 430 minus 37 times root 2 over 2, close parentheses. And then I want to take the inverse tangent of that answer. Now, they probably want the answer in degrees and not radians. And right now, I don't know if you can see it, it's reflecting a lot. My calculator's in radians. That's a little R that's highlighted right there. So I need to change my settings. So I'll go to Shift, Setup, and I'll switch to degrees. And it's a little bit hard to see, but that's a highlighted D now. I want to find the inverse tangent of this answer, so I'll say Shift, hit the tangent button, that gives me my inverse tangent of the answer. And that's equal to approximately 3.71 degrees, and that's from the horizontal. So we might say that this is 3.71 degrees north of east, because if this is east and we're going north of that, that's north of east.